All right, in this problem, we are given a triangle with 3 sides provided. Okay, we don't know the height. That's okay, because what we're going to be asked to do here is figure out the area of this triangle, and we can use Heron's formula to do so. So you're looking at Heron's formula right here. And who is Heron, and what does he know about triangles? Well, he knows that when we have 1, 2, 3 sides provided, we can plug our information into this formula, and it will give us our area. Okay, so we can use Heron's formula when we're trying to find area. When we're trying to find height, I'll do another video for you. You may be given the area of the triangle and 3 sides, and that allows you to find the height of that triangle as well. But that's a little bit more complex. Let's start with level 1 type of stuff here. Okay, so I've got an A, B, and a C. Probably should have a grouping symbol cutting that off. An A, B, and a C. That's just coming from your sides. It does not matter which one's your A, which one's your B, which one's your C. Just make sure if you put 13 in for A, you can't put 13 in for B or C. You got to use the other 2 values, okay? But what in the world is this S that's popping up over and over and over again? S is going to stand for your semi-perimeter. S is your semi-perimeter. Just like a semicircle, which is half of a circle, semi-perimeter is half of the perimeter. Well, how do we find the perimeter of a triangle? You all know how to find perimeter of a triangle. Add up all the sides, get your sum, there it is. Okay, we just need to do that same thing, 13 plus 12 plus 9, but we want to cut that in half. We only want a semi-perimeter. So here's that. This is how you find a semi-perimeter. It's just going to be S is equal to A plus B plus C divided by 2. Okay, so we've got A, B, and C. Again, that could be my A, that could be my B, that could be my C. There's no order in which they need to be placed in. All right, so let's just say A, B, C, and let's solve for the semi-perimeter first. Get the perimeter and basically just cut it in half. So 13 plus 12, that's 25. Plus another 9, that's going to give me 34. So our semi-perimeter here is 34 divided by 2, which is a nice, neat 17. Happy to see we're not getting decimals there. If we did, no big deal. Just makes our work later on a little bit more challenging. Okay, so our semi-perimeter is 17. If we look in Heron's formula, we've got 1, 2, 3, 4 places where S goes. Well, our semi-perimeter is 17, so that's a 17, that's a 17, 17, and 17, okay? The good news about Heron's formula, it's not a tricky one to memorize or understand. If you look, we're just taking our semi-perimeter and subtracting one of the sides, semi-perimeter, subtracting another side, semi-perimeter, subtracted by the third and final side, and then we're multiplying all those together, and then one last time by the semi-perimeter. Okay, so this formula has a pattern to it. Usually formulas that have some kind of pattern, typically kids can memorize those easier and don't have to go to their cheat sheets as often. So here's what we're gonna do. We're gonna rewrite his formula out. Wherever there are S's, we need to replace those with 17s. Wherever there's an A, I'm gonna put a 13. Where there's a B, I'm gonna put a 12. And where there's a C, I'm gonna put a 9. And once we calculate all this out, we will know the area of this triangle by just using its 3 sides provided. So let's do that now. Area equals square root of S, semi-perimeter, 17 times 17 minus A. Remember my A was 13. 17 minus 13 times 17 minus B, 12 times 17 minus C, which is 9. So now we were going to have 4 terms after we simplify each of the grouping symbols. 17 minus 3, that's going to leave me with just 4. 17 minus 12, that's going to leave me with 5. So 4 times 5 times 17 minus 9, which is 8. And then don't forget to multiply 17 at the end by all of it. So I'm going to use these smaller values first, just makes it easier for me to do my calculations. 4 times 5 is 20, times an 8 and a 17. You can write it out like this, separate them. 20 times 8 is 160, times 17. I just got to get a calculator real quick to do that fast. 17 times 160. That's going to be 2,720. Okay, now, one thing we notice up here at the very start is we had the square root over the top of all of this information. So it hasn't gone anywhere this whole time. We're still taking the square root of these values, and now we got this really large value. I honestly don't know what the square root of that is, so we're just going to go back to the calculator for it. Square root of 2,720. There's a reason I didn't know. It's an irrational number. It's not a perfect square. Comes out to 52, so area equals 52.1536. I'm just going to round this, so I'm going to give an approximate calculation, and I'm going to round down to just an even 52 inches. So our area of this triangle, if I want to be exact, I can be exact. If I want to round, I would just round this to 52 inches. Okay, so 52 inches squared is our area of this triangle provided if its side lengths were 13 inches, 12 inches, and 9 inches. This is what you would do. Heron's formula, great use when you are provided 3 sides but no other information about the triangle. Okay, so again, I am going to make a video where I teach you guys how to find the height of a triangle when given 3 sides. All you have to understand there is that area equals 1/2 base times height. We'll have to do some literal equation work to move terms around and get it to where we want to find height as opposed to finding area like we normally would. Okay, but again, if you're given a triangle, doesn't matter what it looks like. If you have all 3 of the side lengths, Heron is the dude you want to go to. Look him up. Great formula. Study hard and good luck on your upcoming test.